Good morning, developers. My name is Rob, and this video is part of a larger course on MediaSoup and how to use the API, how to leverage the Node module and the front end to make a live streaming or a video conferencing app. This might be all that you need, but if you are looking for more detail, I will drop a link in the description. In this video, we are going to talk through how a MediaSoup call works. What are the moving pieces? What under the client here? What are the glossary terms, so to speak, or parts? Same thing over here. We looked at the docs. We looked at what MediaSoup says about itself, what it can do. Now we want to talk about the process. And this might be the most valuable video in this entire course because, yes, the code is important. Yes, SVC and simulcast and metering a connection. Those are really fun, cool ways to scale the platform. But if you can't get there, if your code doesn't work, if you're not actually connected, it won't make any difference. And this is where the tendency will be to either give up out of frustration because you don't understand how or when something happens, or you misunderstood a term, or you troubleshoot something for 3 days. That literally happened to me. I didn't understand when an event was happening, and instead of looking in that event, which I wish I had known about, I literally burned almost 3 days troubleshooting, trying everything I could think of, getting frustrated, coming back to it eventually. Oh, it's this one line right here. Every developer has dealt with that, but if we can figure some of that out right now, it will be so useful. So come back to it throughout the course. When we're doing something and you don't understand why, or you can't remember, wait a minute, what you just said was really confusing, Rob. We're not going to get into API details here. This is just going to be a high-level overview of the moving parts and how the connection happens. The transport process and how we get those transports set up is really what we are after. So again, we've got the server over here, and we've got the client over here. Okay, and that's an important starting point. The server, it exists. Unlike WebRTC, and I'm going to make that contrast occasionally because WebRTC is by far the most common technology that we're going to compare with. Like I said, we looked at the docs. MediaSoup said it is a WebRTC based thing. So if you're using the browser, we're not going to be using RTC peer connection, but it uses all the protocols and it takes the same approach that WebRTC does. So we're going to naturally contrast it with WebRTC, which doesn't have a server. So this is thing one. We have to start on a server, and everything is going to go through there. So unlike WebRTC, where a client uses the server for signaling purposes, and once the two clients have negotiated, the server goes away and the two peers are connected. That's not how MediaSoup works. The client will remain connected to the server and no one else. So there will be an upstream from the client to the server, and there will be a downstream from the server to the client. There won't be any talk directly between clients. Yes, it gives up some of the power of WebRTC, that direct connection, but we gain so many things with it. It is absolutely worth it. Okay, so MediaSoup Server, it is a Node module. It is just a Node module. There's no media server, there's no Linux package, nothing like that we have to install or work with. It's just npm install MediaSoup. So I love that. The MediaSoup Node module starts with a worker. Yes, there are some methods and properties and other things that we could look at when we get to the docs, but MediaSoup's main job is going to be to create a worker. And a worker is just a thread. It's a sub-process written in C++ to manage the next thing down, which is a router. Okay? You can have many workers as you have threads, so maybe you have 32 workers. In our example, we're only going to have one. You can have lots of routers. Every worker can have 1,000 routers. In our example, we'll only have one. So in your head, if you want to have a MediaSoup Node module with 1,000 workers and every one of those has 1,000 routers, that's theoretically possible. Although I don't think there are any 1,000 core machines out there. But MediaSoup has a worker has a router, and a router has a transport. And a transport is the thing that actually connects the server with the client. Both of them will have transport. So this is the mechanism for transmission, for transmitting back and forth the video and the audio feed, the screen, whatever it is that you're passing. All right, so the worker is a sub-process. The router, that's more like an endpoint. So just like, say, in an Express server, you've got an API. the client is going to come in and hit a particular route. The router is that entry point into the entire MediaSoup server, the SFU itself, that application. The router itself will have transports, and a transport will have both, or optionally, I guess, both producers, and it will have consumers. And a producer is nothing more than an audio or video stream being injected into the router by a client so that another client can consume it. And a consumer is nothing more than an audio video stream that is being pulled to a client. These are where we are trying to get to. These are the important things, the producers and the consumers. A client is producing or upstreaming data, and a consumer is a client downstreaming or pulling data. The stuff above it, they only matter because we have to have them to get to producer consumer. Don't get me wrong, they're really important. Everything here is. But this is ultimately where we are trying to get to, where we have producers and consumers. And there's a caveat here. A transport cannot have both when we are in WebRTC, when we're in the browser version of MediaSoup. It doesn't matter why. We don't need to talk about it right now. It's architectural decisions. But a transport is one way, meaning you can have a transport with a whole bunch of producers or a whole bunch of consumers, but not both, because it can only go up or it can go down. It can't go both ways. So from the top, MediaSoup has workers, workers have routers, routers have transports, and transports have producers or consumers. And consumers are dependent on producers, over here at least, because you cannot have a consumer if you don't have a producer. You can't have producers without consumers, although they'd be kind of pointless. If you don't have a producer, you don't have anything to consume. So consumer is kind of at the bottom of the hierarchy, though it's technically a peer with a producer. It is dependent on producers. Both of them come from transports on the way back up. Okay? On the client side, a client has, it's literally a JavaScript library called MediaSoup Client. We'll pull it down from NPM. We'll load up a script tag. There's multiple ways to do it, but it is the client library, right? There's the Node module, Node.js, and there's the JavaScript part, the browser, okay? A client does not have a worker. It doesn't have a router. Instead, it has a device. And a device is the client equivalent to a router. So this is the thing that's going to connect to the router, the device, router, okay? Underneath the device is going to be the transport. So once we make the device, we will make our transport from it. Once we've got our transport, we'll have the exact same thing over here. We will have a producer, and optionally we will have our consumers, or the other way around. Same as over here. You make a transport, it goes one way from this side just like it does from that way. Okay? So these are all the moving pieces, at least the main ones. There's a few other, but the client is going to have a device that is going to connect to the router. The router was made by the worker, which was made by MediaSoup. The router over here, when these two things are ready to connect, and we're just about to get into that process, the client is going to ask for a transport to be made. There'll be a transport on this side. There'll be a corresponding transport on this side. The client is going to say, hey, I want to produce something. This side will make a producer for that transport, or for a given transport. And then the front end will do exactly the same thing. So there's always going to be the counterpart or corresponding part on the other side. So moving on to the process, I'm going to draw at the bottom here. This is going to be our server, and over here we've got our client. And when we start up, everything has to start up over here. This is our SFU, or our node server. It's also something else, okay? It is also our socket IO server, or you can call it your signaling server. If you wanted to use WebSockets, whatever you want to do is fine. But just like in WebRTC, when we over here on the client is going to initiate the request. The client is ready to create a transport and start streaming back and forth. We have to negotiate before we can do that. We need ICE candidates, ICE parameters. We need some keys in order to make sure the connection is encrypted. Why can't we just use Socket.io to do this whole thing? It's not really made for that. Socket.io or WebSockets, and I'll use those interchangeably again so I don't have to qualify, but it uses TCP, and we don't want to use TCP for something like this. Even if you can use UDP some other way, MediaSoup is awesome because it is made to do this and nothing else. Now, not really nothing else, but it is blazing fast at passing video and audio streams back and forth. So we want to use the SFU for what it's good at. The SFU being MediaSoup, meaning we want to pass video streams back and forth. That is what we want it to do. We need something, though, for the ping pong game back and forth that you're about to watch. As the device needs information from over here, we're not connected yet, so we're going to pass that back and forth using WebSockets. Even once the transport is connected, we want that to be dedicated for our producer or our consumer, our audio feed and our video feed. We don't want that to be something that WebSockets can do. So that's what we have our Socket.io server here for. So this will be the first thing we set up. We'll also set up the signaling server so that the client has a quick and easy way to communicate until we're established. Exactly the same thing as WebRTC. With that, we will create inside here a worker, and from that we will create a router. And in the second project, we'll have rooms, and each room will have its own router. We won't have unlimited number of workers to work with because we are limited on the number of threads, but we'll create these two pieces. In part of that router, we are going to pull something out of here, and it will be the RTP capability. So I got RTPC there. This is what the router is saying I will accept. We're going to put the media codecs in there so that who's ever over here can't just show up and send us anything. We have the ability to limit it to whatever it might be. So these things are set up, the worker and the router. We don't have anything else yet. The server is just going to wait until the client is ready to connect. The client is going to load up its device, and that comes from the MediaSoup Client library. And it's also going to load up, let's grab Socket.io here. I've got the colors back here, but just ignore that. The Socket.io connection is where we are going to start. It will ping over here and say, hey, I'd like to chat. And the server is going to respond with this RTP capability. That's going to go back over like so. So we get the RTP capabilities. We're going to load that into the device. So from now on, the device knows what the router it is connected to is capable of. Again, the device and the router are the two things that connect. This sets up everything. We can't go anywhere until we do this. Once we have done this, we can request a transport. And this process is going to feel a little bit arduous when you build it, because what we'll have to do is we will have to send up an event to the server saying, hey, I'd like a transport. The server is going to respond with, okay, I made a transport for you, but we're not connected yet because we are going to use this other protocol, this SRTP, real-time transfer protocol, and it needs to be secure. So I'm going to send you back some keys. It's DTLS is what it will send back. But I've only got half of the keys. So I'm going to send them back over to you. Okay? You've got them now. Now you can make your own transport. And the device is the thing that is going to make the transport. So we've got a transport on both sides. Hey, I'd like to make a transport. Okay? Sure thing. Here's your keys. The transports, right? They exist on both sides. And the transport is made with this half of the keys. And then when we're ready to produce, producing being, so we've got, I'll just put gum here for get user media. We'll grab the feed from that, the mic and the camera feed. We'll run on that produce. So on here, we will now have a producer, except we'll only kind of have it because there's a whole bunch. This is one of the really confusing parts when we get into the API. When we run produce, or when we run consume, it actually is kind of like bookends. It starts the process. Remember, we're not connected yet. The router and the device, they have transports, but they're not actually connected. We have to run produce. When we run produce, we're going to send another event up to the server saying, hey, I've got a track now. Okay? Get user media. And I'd like to produce. But we're not connected yet. We do have transports though. So on produce, we're going to request the transports connect. And for that part, I'm going to put underneath of it here, we are going to send up the other half of the DTLS, the keys. So when you created the transport, you sent me the keys. Now that I have something to produce, I'm actually ready to connect. So let's connect. Here's the other half. And at this point, we will now be able to connect the router right here to the device over here. This blue line represents our connected transport. It will either be a producer or a consumer, or a whole bunch of producers or a whole bunch of consumers, but we can now actually connect because both sides have passed their DTLS keys from both sides, and what we're capable of, and so on. All right? Once we are connected, we still have to send over another event. We have to say, hey, would you please start producing? So we want to produce, but we're not connected, so please connect the transport. Now over here, we will create our producer. The server will do that. It will send back over its ID. I know I already have produce over here. As I said, it's kind of confusing because produce starts, and before it ends, we have to connect the transport, and we have to ask the server to actually start producing. Once it finishes, now we've got a producer, and there is data going back and forth on our RTP connection. Okay? That is how producer works every time. Every single time. Once you get this down, it'll start to become commonplace, but it doesn't matter how many clients we have connect. We have one over here that connects and it wants to start producing. It's going to go through the exact same process. We have another one up here, and it's got two streams. It's going to send two different video camera feeds. It's going to have to do the exact same thing twice. Now, the only caveat is that you can use the same transport for more than one producer if you want to. We'll do it both ways in the projects, but this is the same no matter how it works. The good news is it's almost exactly the same for consuming. Over here, we start here with the device. If we've already established the capabilities, the RTP capabilities, we don't have to ask for that again. So that's a win. We have to ask for a transport. So we'll make a request to the server saying, hey, I'd really like to talk. And the server says, oh, you need another transport. That's fine. Let's make another transport. There we go. I had to switch markers. We've got another green transport. Now, we're not connected yet, so I shouldn't have drawn that. I don't want to be confusing. But, hey, we'd like another one of these so that I can consume. I'm producing on the blue. I want to consume. And let's go ahead and draw those arrows in. That one goes that way, and this one goes this way. Producers upstream, consumer downstream. I want to make a new one, though, right? I want to consume. So create me a transport. It will send back half of the keys, but they're not connected yet. We'll have to run consume. Let's change colors. This is going to make our consumer, but not yet, right? Again, bookends. We have to connect. So send up the front end's half of the DTLS parameters. The server will fire up its consumer. It will let the front end know, hey, you're consuming now, and they're connected, right? It is brilliant. It is complicated, but it is incredibly logical. It's not synchronous. It's very asynchronous, and it's going to take some time to get used to all of these moving pieces. But a quick recap. The server, it has to exist. Every client is connected directly to the server. If this client here is consuming or is producing, we'll put producing here, and this one here is consuming. It's consuming from over here. These two clients, they don't know each other exists. It does know the feed that it's getting, and this one knows the feed that it's passing, but these never talk to each other. Okay? MediaSoup. It is the top level on our node server in addition to a socket IO for our signaling. So this process, this negotiating, and I passed over that a little bit here, but when we send back the transport so that it can be created on this side, we're not just going to send back the keys, we're going to send back ICE candidates, just like WebRTC. This is how you get to me. All that process happens not on the MediaSoup part, but on the socket IO part, on our web sockets, on our signaling server. MediaSoup has a worker has a router has transports, a transport has either one-to-many producers or one-to-many consumers. That's the server's job. It holds the producers so that others can consume, and it holds the consumers that others are producing too. The client has a device. That is where we connect. The device will connect to the router. A device has transports. A transport has either one or many consumers, one or many producers. That is how the process goes. Again, it is complicated when you first get here, but with a little bit of time and practice and walking through step by step, it will make sense and you will get it down. And we can do some pretty awesome stuff once we are connected. Please stick with it. There are so few people that know how to do this, that can build video conferencing or live streaming that can scale as high as your hardware can. It's going to be exciting.